In 4.4, we're going to look at factoring quadratic expressions. We'll learn how to find common and binomial factors and quadratic expressions, as well as how to factor some special cases. When we talk about factoring, we're really going to be undoing the distributive property. Often we're going to find ourselves looking for the greatest common factor. And this is the largest term that divides evenly into two or more numbers. In the first example, we have 27n squared minus 9n. And we want to find that greatest common factor. Meaning, what's the largest number that divides into both 9 and 27? Well, that number is going to be 9. Then we have the n squared and the n. We want to look and see how many n's do we have in common with both numbers. Both of them have at least one n in them, so our greatest common factor is 9n. If we were to divide both of these terms by 9n, we'll end up with 3n minus 1. But if we wanted to get back to what we started with, we would have to multiply 3n minus 1 by that greatest common factor of 9n. By doing the distributive property in reverse, this is the factored form of the original expression. Let's look at another example. 36y cubed plus 54y squared. These numbers are a little bit bigger. Again, we want to try to find what's the largest number both of them have in common. We can do some trial and error, some guess and check, but we're going to find that the greatest common factor is going to be an 18. Now let's look at our variables. We have 3 y's on the first term, 2 y's on the second, so they both share 2 y's in common. The greatest common factor is 18y squared. We'll divide both of these by 18y squared. 18 fits into 36 twice. Y cubed divided by y squared is 1y, since we're subtracting the exponents. Plus 54 divided by 18 is 3. And the y's are going to cancel out. So this is the inside of our parentheses. Then, to get back to where we started, we'd have to multiply by that greatest common factor, so we'll put the greatest common factor on the outside. And here is our factored form. In order to check and make sure we did our work correctly, what we need to do is go ahead and distribute our greatest common factor back into our parentheses. 18 times 2 gives us 36. Y squared times y, we're going to add the exponents, is y cubed. Then we'll do 18 times 3, gives us 54. And then we'll tack the y squared on. This matches the expression we started with, so we know that we've done our factoring correctly. The next factoring method is factor by grouping. This is going to happen whenever we have 4 terms. And it works because we can draw a line right down the middle, and we can split it into 2 even halves. And we can work with each half separately. If we're to look at just 4x cubed plus 8x squared, I want you to pause the video and pull out the greatest common factor between these 2 terms just like we did above. The greatest common factor is going to be a 4x squared, and if we divide both terms by this, we'll end up with x plus 2. Then if we look at the other side, negative 5x minus 10, our greatest common factor is negative 5. Divide both terms by negative 5, and we'll end up with x plus 2. Now we're going to look and see if we notice any similarities. We should notice that in both sets of parentheses, we have the same exact expression. We're going to bring that together as just one set of parentheses, x plus 2. Then we're going to take the values that are on the outside of the parentheses and put them in their own set, 4x squared minus 5. And this gives us the factored form of our original expression. Another method of factoring is factoring trinomials, and this occurs when we have 3 terms. First, we want to look to see if we have a greatest common factor. 2, negative 5, and negative 12 have no number in common, so we can skip to step number 2. And we're going to say, well, what numbers multiply to the product of a times c? Remember that a is going to be the number in front of the x squared, which is 2. B is the number in front of x, negative 5. And c is the constant, negative 12. So if we do a times c, we'll be doing 2 times negative 12, which is negative 24. And we want to list what are all the numbers that multiply to negative 24. If we treat it like a positive just for a second, we're going to do 1 times 24 would, We could do 2 times 12, 3 times 8, or we could do 4 times 6. To determine which set of these numbers we're going to use, we need to decide which of these are then going to add to our b term, which is negative 5. Now we need to address the negative. If we need to multiply to a negative 24, one of these numbers has to be negative in each pair. And since we're trying to add to a negative number, we need the larger number to be negative, so our ending result is negative. After making the larger number negative, we can now see which of these pairs will add to negative 5. 1 minus 24 is negative 23. 2 minus 12, negative 10. 3 minus 8, negative 5. So we can stop right here. We can see that 8 minus 5 is going to give us the negative 5 that we're looking for. This is important because our middle term was a negative 5x. We can replace a negative 5x with a 3x minus an 8x. If we combine those like terms, it gets us right back to the single term we started with. Then we can add on our starting term, which was 2x squared, and on the back we'll add that negative 12 back in. Now we have 4 terms, and we can do factor by grouping. The whole point of this AC method and that table we just made was to find 2 terms that we could use to replace our middle term to allow us to split this perfectly in half. To finish our factoring, we need to look at each side individually. Since 2 and 3 have no number in common, we'll look at our x's. We have one x that's in common, so that's our greatest common factor. Divide both values by x, and we'll end up with 2x plus 3. On the other side, negative 8 and negative 12, they can both be divided by a negative 4. And that's going to leave us with 2x plus 3 inside our parentheses. We'll look for that common set of parentheses. We have a 2x plus 3, and since they're both the same, we're pretty sure we're on the right track. So our first set of parentheses now becomes 2x plus 3. If these two sets of parentheses were different, you'd want to go back and check your work. Then we'll take our outside values, bring those together, x minus 4, and here is our factored form. We can also check our work by multiplying these two binomials together. You may have seen this with the FOIL method before, where you'd multiply the 2x to both terms in the other set of the parentheses and the 3 to both terms in the other set. That's one method. I'm going to show you a new one though. This is what we're going to call the box method. We're going to take our first set of parentheses and we're going to put it across the top of our box. And then we'll take our second set of parentheses and put it on the side. So x minus 4. Then we're going to multiply the values that are outside together to get some number inside. So 2x times x is 2x squared. 3 times x, 3x. 2x times negative 4, negative 8x. 3 times negative 4, negative 12. Now we can look for any like terms, and we're going to combine those together. We have a 3x and a negative 8. If we add those, we're going to end up with a negative 5x. Then we still have the 2x squared by itself and the negative 12 by itself. When we put this back into standard form, we're going to see that our solution matches the original equation. So we know we've done our work correctly. We'll do one more example together. First, we're going to look for greatest common factor. 3, negative 7, and 2. Definitely not. So we're going to identify our A, B, and C. A is 3, B is negative 7, and C is 2. Then let's make our table. What is A times C? That's going to be 6. Let's make a list of all the numbers that multiply to 6. 1, 6, 2, and 3. Not a very long one. So we're going to see which of these now will add to a negative 7. Since we're trying to multiply to a positive 6, but add to a negative 7, we're going to have to make both of our numbers be negative. Because two negatives multiply to a positive, but they add to a negative. Negative 1 minus 6 gives us negative 7, and we can stop right here. We've already found the two terms we're going to use. We'll split this negative 7x to be a negative 1x minus 6x, and then we'll add on that 3x squared up front and the plus 2 on the back. Split it in half. Looking at our left-hand side, these both have an x in common, so we'll end up with 3x minus 1. The right-hand side, we can divide both by a -2. So we'll end up with 3x minus 1. We do have the same sets inside both of our parentheses, so we're on the right track. Our first set of parentheses will be 3x minus 1. Take those outside values for our second set, which is x minus 2. And here's our equation in factored form. In the next example, we have x squared plus 6x minus 16. Remember, the number in front of this x squared is just a 1. And that tells us that our a value will be 1. Pause the video and finish factoring this on your own. Make sure you're careful with your positives and your negatives. On this problem, we'll get x minus 2 times x plus 8. Let's make a connection with this problem. If we look at the numbers in both sets of our parentheses, and we compare that to the numbers that we use to split our middle term, do you notice anything? We should be noticing that they're the same. So anytime we have an a value of 1, we could actually skip factor by grouping and just go to what two numbers would equal our middle term. Those become the numbers in our sets of parentheses. So there's a shortcut. We also have some special cases of factoring. The main one we're going to look at is called the difference of squares. And it says if our first term could be rewritten as some number squared, we're using subtraction, and the second term can be written as some number squared, then we can factor it out into the following format. First, we have 81x squared minus 9. Well, 81 is a perfect square. We find that by doing 9 squared. Well, if we want to get an x squared, we'd have to do x times x. So 9x all squared is the same thing as 81x squared. Then we're subtracting. Well, how could we rewrite 9 as some number squared? 3 times 3 gets us back there, so 3 squared is the same thing. This tells us now that our a value is going to be 9x, and our b value is going to be 3. Then we can plug it into our formula, which says a, which is 9x, plus b, which is 3, multiplied by a, 9x, minus b, 3. This is now the factored form of our original problem. On the next example, ask yourself, what number squared gets you 121? And what number squared gets you 49? Pause the video and finish the rest of this on your own. Here we'll end up with 11x plus 7 times 11x minus 7. This difference of square method is really handy and pretty fast, but it only works if both terms are perfect squares, and it only works if we have subtraction. If there's addition, we cannot use this formula. Let's do a check here on our first problem to see why. So we're going to do 9x plus 3 on top, and on the side, we're going to do 9x minus 3. Then we'll multiply this out. 9x times 9x gives us 81x squared. 9x times 3, 27x. 9x times negative 3 is negative 27x. Negative 3 times 3 is negative 9. Looking for our common terms, we have 27x minus 27x. So these actually cancel each other out. All we're left with now is 81x squared minus 9. This is the same thing that we started with. So we can see it's really important that we have one term that ends up being negative and one that ends up being positive, because then they're going to cancel each other out to get us back to where we started. Lastly, we'll look at multi-step factoring. In our first example, we're going to see if we have a greatest common factor. 3, 21, and 30, all of these can be divided by 3. So we're going to put that on the outside, and then on the inside, we'll be left with x squared plus 7x plus 10. Now, with the inside, we can use our AC method. Our a is 1, our c is 10. So we're going to say, well, what numbers add to 10? But then add to our middle term, which is 7. We can do 1 times 10, which is 11, 2 times 5, and that would add to 7. We can replace now the 7x with a 5x and a 2x. So we'll have 5x plus 2x. we'll put our x squared on front and our 10 on the back, and we can do factor by grouping. We have a common term of x on the left, leaving us with x plus 5. And then we have a common term of 2 on the right, leaving us with x plus 5. We have a common set of parentheses, so we're on the right track. Our first set then becomes x plus 5. Take those outside values for our second set, and we'll have x plus 2. However, before we finish and say this is our final answer, we need to remember, back from the very beginning, we had this greatest common factor. We need to remember to put our greatest common factor now out in front of our expression. Now we have our completely factored form. We first use the greatest common factor method, then we use the AC method. So this problem is no different from what we did in example number 3. However, in the very first step, we pulled out a greatest common factor and had to remember to bring the greatest common factor back down in our final answer. The next example, we have two terms. We're first going to look for greatest common factor, but 16 and 81, they don't have any. So we might start to think, well, do we have difference of squares going on here? 16 is a perfect square. We can write 16 as 4 squared, and 81 is a perfect square. That's 9 squared. Now we need to look at this x to the 4th. Well, if we did x squared times x squared, that would give us x to the 4th. So we could say that x squared, all squared, is the same thing. This means we'll have 4x squared plus 9 times 4x squared minus 9. Well, let's look at this again. In the first set of parentheses, we have plus 9, so we can't use difference of squares here. But in the second set, we have subtraction. Let's see if we can apply the difference of squares again with our second set of parentheses. 4 can be written as 2 squared, and x squared is x squared. We're subtracting 9, well, that's the same thing as 3 squared. So we can apply difference of squares again. We're going to have 2x plus 3 times 2x minus 3. And that all came just from that second set of parentheses. But we need to bring down our first set of parentheses because it's still there. We're still multiplying by 4x squared plus 9. Now we're just going to have 3 terms in our factored expression. And with this problem, what we did is we used our difference of squares, but we just had to use it 2 times.